Alrighty, so topic 4 of our factoring unit is where we bring it all together. So we've learned 3 different methods for factoring, but they all kind of work interchangeably depending on the problem. So we're going to use this time to, again, bring it all together and see how those 3 methods interact. So looking at the green factoring flow chart that you received at the beginning of this unit, it looks like what I have on my screen right here. You probably put it in your resources tab. This kind of gives you a flow chart, a map, if you will, of how to use all the different methods together. So it says start here, right? First thing it says is to factor out any greatest common factors first. Just like we learned topic 1, you want to make sure you start with the greatest common factor. Then you follow the arrow, and next it says, can it be grouped? If your answer is yes, then you go ahead and group it and you're done. If your answer is no, then you're going to go through a series of questions. Now, you're not going to learn about this or this until topic 5. So for now, your no is actually going to jump all the way down to the x factor, okay? And you'll notice if you can factor it using the x factor, your answer is yes, then you're done. I didn't put no and or prime on here because you'll learn in topic 7 that there are certain things that even after you go through this whole flow chart, even if you can't use the x factor, that doesn't mean that it's prime. So for now, we're just going to start with GCF, move to grouping, and then move to the x factor. Okay? So we're really just going to jump in and use the flow chart to answer each question. So number 1, starting at the beginning of the flow chart, factor out any greatest common factor first. Looking at number 1, I can take out a 2. So I'm left with x squared plus x minus 2. Okay? Then I move on down. Can it be grouped? Well, no, because I don't have 4 terms left over inside of my parentheses. So I go no, moving this way. I can't answer that, but now it asks me, can I factor using the x factor? And the answer is yes. So here's where I draw my x. The top of the x factor is a times c, bottom is b, and now I figure out what times what multiplies to -1 and adds to +1, or multiplies to -2 and adds to +1. So 2 and 1, but I need something to be negative, and in this case, it's the 1. Now, wish I could have like a big old like news flash, some sort of thing that popped up on the screen or whatever. I have one trick to teach you that I haven't brought up yet. When you have an A of 1, okay, right here. I know it used to be a 2, but for right now it's an A. When you have an A of 1, you can actually skip doing all the grouping with the x factor, and the 2 numbers you put on either side, those become your actual factors. Now that only works when A is 1. Okay, so what I mean by that is x plus 2 and x minus 1 become our answer. Okay, so let me go through it the long way and show you just to prove to you that it works. So I'm going to take x squared, I'm going to use my 2 numbers to split it up, so plus 2x minus 2. I group, take out a -1, my factors are x minus 1 and x plus 2, like I already showed you here. Okay, now again, that only works if A is 1, and I'll kind of come back to this a few times during this video. But I wanted to give you that shortcut just in case you have maybe figured out yourself, or if you're just looking for something to make this all go a little faster. Okay, now we're not quite done with this problem because at the very beginning we took out a greatest common factor of 2. So I need to bring that next to my answer before I box anything in. That is my final answer altogether. Okay, so next problem, again, kind of going my flow chart over here. First step, it says to always start with our greatest common factor. So looking at those problems, I see that I can take out a 6 from every single piece. So I'm left with x cubed minus 4x squared plus 3x minus 12. Okay, so check. Do the first thing on the flow chart. Move it down. Can it be grouped? The answer is yes. So I'm going to group it, and I should be done. So what's left over in here gets grouped. So I'm going to take out x squared. And over here, I'm going to take out +3. So I'm left with x minus 4 and x squared plus 3. However, I took out that 6 at the beginning. You have to bring that down and make it part of your answer. Okay? Number 3, same process. Again, I'm going to refer to this flowchart. First step is always to check for a greatest common factor. So I look and I see x squared 4. Nope, I don't have a greatest common factor. So I checked. I shouldn't have one. Can it be grouped? The answer is no. So I'm going to move this way. Don't know that, don't know that. But can I use the x factor? I sure can. So I'm going to draw this. A times c is 24. B is negative 4. So now I try to think of two numbers that multiply to 24 and add to negative 4. So if we struggle with this, we'll make a list of factors. 1 times 24, 2 and 12, 3 and 8, 4 and 6. I don't know if you've noticed. I'm trying to get a positive 24, and I'm trying to get a negative 4 when I add. Well, 1 and 24, those add to 25. 2 and 12 adds to 14. 3 and 8 adds to 11. 4 and 6 adds to 10. Even if I made them all negative, they still wouldn't add up correctly. So I don't have a number here that I can think of. There isn't one. I don't have a number here. This is where you would write the word prime. Okay? This is a prime problem. Now remember, I said there is the option of no over here on the flowchart. Yes, this is a prime example because I can't think of two factors, but that doesn't mean that it can't be broken down, and we'll talk about that in topic 7. Okay, but it is prime because it doesn't have any factors other than 1 in itself. Okay? That only happens if you can't come up with these two numbers. And I would say don't give up too easy. When you have tests and quizzes and things, I'm not going to make 75% of the test prime. That would be weird and not helpful. So make sure that you are limiting yourself. Like there might be 1 on an entire 25 question test. Okay? Alrighty, so let's keep trucking. Number 4, again, starting with the greatest common factor. This gets very redundant. I look at these, 6, 8, 20, 15. Well, 6, 8, and 20 are even. 15's not, though. 15 just has factors of 3 and 5. So there's no greatest common factor, okay? But I checked. Can it be grouped? The answer is hopefully yes, because there's 4 of them. So I'm going to group these two together. I can take out a 2f squared. So 3f minus 4. Then over here, I look to see what can I take out. I could take out a 5. So I'm going to take out a positive 5, even though that's not going to be right. And I'm left with this. Well, what's left over in the parentheses of both of these don't actually match. On my left-hand side, I have a negative 3f. Over here, I have a positive 3f. So what would fix this is if instead of a positive 5, I took out a negative 5. That would leave me with negative 4 and positive 3f. That makes more sense. So 3f minus 4 and 2f squared minus 5. That would be my final answer. There was no greatest common factor to bring down, so I'm done. Okay. Number 5 looks kind of funky, but we'll see that it's okay. Greatest common factor? Nope. There's not even really any numbers to look at. Can it be grouped? Nope. Can I go this way? X factor. The answer is actually yes. I can do the X factor. You may be looking at this thinking, what are you talking about? But let's pretend this was written as instead k squared plus 0k minus 49, right? That would mean that A is 1, B is 0, and C is negative 49. So on the top here, I've got negative 49. On the bottom, I've got 0. So I'm trying to think of something times something that gives me negative 49 that adds to 0. Well, 7 and negative 7. Okay? If you wanted to use the shortcut I taught you, your answer would just be k plus 7 times k minus 7. Okay? I did that earlier in the video, but I will show you the long way how this works out. So I'm going to split apart my middle term and then group. So I've got k and then k plus 7. Take out negative 7 would be k plus 7 again, and then I get that same answer. Remember, you can only do that when A is 1. If A is not 1, it doesn't work. Okay? Number 6, same thing. Again, flowchart. Is there a greatest common factor? Sure is. We can take out a 12 and an x squared. So really I'm just left with 2x minus 1. Well, that's just the first step. Can it be grouped? The answer is no, because there's not 4 terms. Going down this way, can it do the x factor? Well, no, because it's not a trinomial. I don't have an a, b, and c. So is this prime? Well, no, because I took something out, right? I did something, so it's not prime. It's just I only could do one thing. Just take out the greatest common factor. Alrighty, number 7. Again, same process. Greatest common factor first. I'm going to take out my 6. Okay. What's left on the inside? Can it be grouped? No. Can I use the X factor? Sure can. The top, I'm going to have a 10. Bottom, I'm going to have 11. So I think about what times what gives me 10 and adds to 11. 10 and 1. Again, notice A here is 1. After I took out the 6, A is 1. So I know that the 10 and the 1 become my factors. X plus 10, X plus 1. But I have to move the 6 that I factored out down into my answer. Okay. Number 8. Is there a greatest common factor? No, there's not. Can it be grouped? No. Can it be an X factor? Yes, can. Okay. Again, if we expand it, we just put a 0x in the middle, we still have an A, a B, and a C. Okay? So on the top, I'm going to have negative 36. On the bottom, I'm going to have 0. Now here's an example. A is not 1, right? So whenever I come up with these numbers on the side, I can't just skip to the answer like I did on number 7. Okay? So I'm thinking 6, negative 6 will work here. So I have to split my middle term. Again, I cannot shortcut this problem. The answer is not x plus 6, x minus 6. So we're going to split it. Group. Take out a negative 3 here. So I'm left with 2x plus 3 times 2x minus 3. And there's my answer. Okay, so again, A was 4, so I couldn't just move those straight into my answer. It doesn't work that way. Okay, you'll see that on number 9 as well. So number 9, again, greatest common factor. Answer is yes, there is one. It's a 3. Yep, 3. So I'm left with negative 3x squared plus 4x plus 15. Okay. Can it be grouped? No, because there's not 4 terms left on the inside. Can I do the x vector? You betcha. Okay, so I'm going to do A times C. So I get negative 45 on top. And then I get 4 on the bottom. So what times what gives me a negative 45 and adds to 4? I'm thinking 9 and 5 might be helpful here. 5 is going to have to be negative to produce a negative product and add to 4. Again, A is not a 1, so I can't shortcut this. Have to do it the long way. So negative 3x squared, split my middle term into 9x and negative 5x. Now I group and take out, I'm going to take out negative 3x. So I'm left with x minus 3. I take out a negative 5 over here, x minus 3. So I've got x minus 3 times negative 3x minus 5, but at the very beginning of this problem, I took out this 3 from the very beginning, have to bring that one down. That would be my final answer altogether. Okay? Alrighty, I think there's 3 more, is that right? Oh, no, there's 1 more. So number 10, greatest common factor? No. Can it be grouped? No. Can we do the x factor? Yeah. So, again, in this case, A would be 1, B would be 0, C would be 16. So A times C is 16, B is 0. So now I think what times what multiplies to 16 and adds to 0. Well, if I'm going to add something up to 0, I need a positive and a negative. But if I have a positive and a negative, I can't get 16. So I'm in a little bit of a pickle. So this one's prime. Okay, because there are no 2 numbers that will work here and here that will multiply to 16 and add to 0. Alrighty, next problem. Greatest common factor is what I start with, so I'm going to take out a 3. Okay, grouping, nope, but I can do the x factor. So there's an imaginary 1 here. 1 times negative 15 is negative 15. Negative 1 is in my B position. So what times what multiplies negative 15 and adds to negative 1? 1 and 15, 2, nope, 3 and 5. Can't come up with anything. I don't know about this guy. I don't know about this guy. So you may be thinking, oh yeah, it's just like the one above, it's prime. But it's not prime because I still did something. I took out that 3 right from the beginning. So this is my answer, not the word prime. Just because I couldn't break it down further doesn't mean that it is prime. Okay, number 12. Feel free to pause at any point. I'm just going to keep talking through these, but feel free to pause at any point and take over and see how you do, and then just resume and see if you match what I have. So number 12, greatest common factor. Grouping, nope. X factor, yes. So I've got an imaginary 1 here. 1 times 8 is 8. Middle term is negative 6. Think about my factors, 1 and 8, 2 and 4. That's promising, right? They would both need to be negative to add to negative 6, but that's good because a negative times a negative is positive 8. Well, again, this imaginary 1 right here allows me to use the shortcut. So I've got 5 times x minus 2, x minus 4. Again, the 5 came from the very beginning of the problem when I took out that greatest common factor. All right, number 13. This one's a little bit different. It's a word problem, first of all. We're also going to solve it a little bit differently. It says a rectangular painting has an area of 2x squared plus 8x plus 6 centimeters squared. That's supposed to be a square. Its length is 2x plus 2. Find the width. Okay? Think about it in a different way. Let's say the area of a painting is 48 and the length is 16. And they want to know the width, right? Well, again, if you picture a rectangle of 48, length is 16, how do you get this? You would divide, which is pretty much what factoring is. It's just kind of doing it a slightly different way. So if I think about my algebra tile setup, it kind of is a rectangle, right? It's an area model. So I've got 2x squared plus 8x plus 6. Well, if I remember back to the algebra tile stuff from topic 3, I'm trying to create 6 little boxes down here. I can either have those 6 boxes like I just drew those dots, 2 by 3, or I could have them 1 by 6, all right in a row, right? That's really it. I need to think about how to do it, though, so that I have 8 x's. So I'm going to first start by just putting 2 x's over here and 1 on the side, because I have to do that, and that produces 1 box. Well, if I add another row of 2 of the x's, and another one here, I'm up to 4. I'm trying to get to 6, right? If I add 1 more row, I now have 1, 2, 3, 4, 5, 6, 7, 8 x's like I want, and 1, 2, 3, 4, 5, 6 tiles. Well, that could have been made a whole lot easier by just looking here at the fact that they told us the length. The length is 2x plus 2. If I had just started there, I would know exactly how to put it all together. And then I'm just looking for what is left over here on the side, which is x plus 3. Okay? Alrighty, I think that's all I have. Yeah. So use that flowchart to help you make sure that you are covering every step of the process. Make sure that you are always checking for greatest common factor first, then to see if it can be grouped, then do the x factor before you ever call it quits. The biggest thing people forget is the greatest common factor. Both they forget to take it out and they forget to write it down. Like this problem right here, this 5 is missing on so many students' papers. So make sure you're remembering, if you ever take out a greatest common factor, maybe go ahead and at the bottom where you have like an answer blank, go ahead and write it down so that you know that you have to include that in your answer. Alrighty, so let your teacher know if you have any questions. Hopefully when you get to the practice step, which is next, you'll become a pro at this even more so than you already are, and you'll be ready to factor just about anything.